Welcome, Algebra 1. This is section 6-6, Systems of Linear Inequalities. The essential question is, when graphing a system of inequalities, which area do you shade and why? Let's begin. So, solutions to system of inequalities. A system, as you remember from system of equations, is two or more different equations. Well, system of equality is two or more inequalities are in the same system. So when you have solutions to these, they have to satisfy all inequalities in the system. So for example, 3, 0 is a solution because we have two inequalities here. Let's do the first one. And if x is 3 and y is 0, you get 0 is less than 2 times 3 minus 3, which is 0 is less than 6 minus 3. And so 0 is less than 3. Yes, that checks out. Now let's do the other one. Other equation, you'd get 0 is greater than negative 2 times 3 plus 2. So 0 is greater than negative 6 plus 2, which is 0 is greater than negative 4. Is that true? Yes. So 0, 3 is a solution. And just like solving a solution for an inequality, there's more than one solution for a system of inequalities. If we wanted to graph a system of inequalities, the best way to solve the systems solve a system of inequalities is by graphing. So what you do is you graph the first inequality, and graph the second inequality. We did those last section. And then this is different. We shade where they overlap. So this is the different part there. I shouldn't put that. We shade where they overlap. So how do we figure that out? Well, we're going to step our way through that. So in this case here, what is the solution to system of inequalities? If I had these two inequalities here, the shading 2x plus 3 would look like this and just shaded below. And negative 1/2 x plus 1 would be shaded above. Well, the solution is which area they both shade. So if I graph those together, it'd be shading under the blue and above the red, and the only area that does this is this part right here. So this is the only part that's actually shaded. This little corner I'm doing in purple. The other parts would not be shaded. They're not systems. And any point in this area that's shaded is a solution. So let's actually do this ourselves. First one, I'm going to graph the first equation. I'm going to graph this in purple, looks like. So putting a dot at 0, 2, and then going up 1 over 2. Okay, so I got two lines, and this is less than or equal to, so it'll be a solid line. I'm going to draw a perfectly straight solid line through those points. Perfectly straight going in both directions. Okay, do arrowheads. And here's the thing. It's shaded below, so what I'm going to do is I'm going to make really small tick marks that go straight down from the line. This is to indicate which area I'm going to shade. I do this just to know I'm okay. Just to remind myself, okay, I'm shading below this one. You don't shade it in completely, you just do little tick marks, just like I did. So they want to see that when you do work in class. Now graphing the other one, I'm going to shade this one. Let's shade it in red right here. So it'd be minus 1 for the y-intercept, and the slope is negative 1, so down 1 over 1. So, and it's going to be or equal to, so it's going to be solid. I'm going to do a solid line that's perfectly straight through those. Perfectly straight solid line. Straight enough. And perfectly straight going in this direction. And I'm going to be shaded y is greater than or equal to means shaded above. So do tick marks going above the line to indicate I'm going to be shading above the red line. So if you're looking at that graph, which area, and I got 4 different areas. Usually you'll have 4 different areas. Boom, 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 or boom. Which area do I shade? Well, it's going to be below purple and above red, and that happens in this area right here that I'm going to shade. Because it is below the purple line, so I'm going to shade below purple, and it's above the red line. So I'm going to shade above the red line. So this is the only area that includes both areas, so I shade that in perfectly. And I'd never ever cross the line. And that's it. That's how you shade. Let's try some examples. Pause the video. Okay, drafting the first one. I'm going to do this in this brown color. So plus 2 is the y-intercept, and the slope is negative 1, so down 1 over 1, down 1 over 1, and it's going to be greater than or equal to. It'll be a solid line, so I draw a perfectly straight solid line going that way, and a perfectly straight solid line going this way. So there we go, and it's greater than or equal to, so I shade above. So I'll do tick marks going straight up. Just to remind myself, I will shade up. Next one, less than or equal to. And it's negative 2x plus 5, so I'll do plus 5's right here, and minus 2, that's negative 2 over 1, so down 2 over 1, down 2 over 1. Okay, so I'm going to draw my perfectly straight line, and it's solid, because or equals to, and it's solid or equals to, and it's going down this way. Perfect. And it's less than, so I shade below this line. So I do little tick marks going below that line. And then which area is shaded above the brown and below the green? Well, if you look at that close, it's that like top part right up here. So I'm going to shade in this. Got to shade below the green, so make sure I'm shading below the green and above the brown, and it'll be just this area that I'm highlighting in yellow. So that's where I shade. Try a different one. Pause the video. Okay, so I'll do the top one in pink. Y is greater than x. Well, that's like x plus 0, so my y-intercept's at 0. And that's like a 1x, so it's up 1 over 1. So I'm going to draw a perfectly straight line through those. Now it's y is greater than, not or equal to, so it will be a dashed line, just like this. A dashed line. You must make sure you do it dashed or solid. That's key, because the line doesn't count when it's dashed and greater than. So now the graphing the other one, and oh, forgot, we have to shade, it's greater than, so I shade above. So I'll do tick marks above that dashed line, just like this. Just indicate I'm shading above. Now graphing the other one, let's do that in brown. So y is less than 2x plus 1. So plus 1 is here, and then I go up 1 over 1, up 1 over 1, up 1 over 1. So it's going to be like this. Now, and it's also going to be dashed. This is where you want to make sure you have a perfect line, because we are going to have a case where these lines actually never cross. Because this is why you want to make it straight. If you do not make it straight, your lines are going to actually cross because you drew it crooked, and it's shaded below these lines. So these lines actually never cross. They're parallel. They have the same slope, m equals 1, and different y-intercepts. This is b equals 0 and b equals 1. So these are parallel lines. Well, you're shading below the top line and above the bottom line. So the shade in this case is actually between those two lines. And I'm going to shade it in this color right here. So it's kind of like forms a little sandwich here. And this is why you want to have perfectly straight lines, because sometimes it's very hard to see where they cross if you don't use a straight edge. If you just try to do freehand, it'll look sloppy, like my drawing. And that's how you shade the lines. That's it.